Hello, hi guys. Today we are starting on the topic of concurrency in Golang. Okay, so this would be a lot of topics. We will cover individual topic in each videos. We'll start with the Go routine, then we'll go with the weight group, channels, and different type of pattern in concurrency. Likewise, we write a production microservices where we use this all patterns, concurrency patterns in the Golang projects. Okay, we start with the Go routine. So this video is all about Go routines. Go routines is very small topic, but this will give you a understanding of why we use Go routine or concurrency in Golang. Okay, we start with the normal main program. Okay, let's see what how we you can use Go routine. Okay, what is the advantage of Go routine is that so this is your main thread. So whenever you are writing any main program, that means it is a thread. Okay, and inside this you are doing some execution. Yes, a lot of execution you are doing. Okay, and uh, what you need is that you want that so you have some you are hitting some urls, okay, or you are hitting some database and there are a lot of calls, okay, and you and it has nothing to do with your main program, okay, and you only need your that response. Okay, let's say I have a request which needs data from the database. So what it is fetching, it is fetching author detail, okay, and then it is fetching of department detail, and then it is hitting some http calls. Okay, so these are individual three calls. Okay, so from Go routine we can reduce that three calls, and let's say this call is taking how much, this it is taking 1 second, and this is taking 1 second, and this is taking 1 second. Okay, and the combined execution of this all would be 3 seconds, but from Go routine you can make it only 1 second. Okay, that is what is the Go routine. Okay, how we do it, let's say this is the main thread. Okay, in main thread what we do, we call other function, some other function, that is something called hello. Okay, and we can define a function hello. And here what we can do is that we can just do print. Let's do printf, then print hello, and then let's do this one, main end. Okay, so this is so what is happening in main program, you have some hello function. In hello function it is doing something. Okay, it is printing, and then you have main end. So when you execute this program, you will see that first print hello is printing, then main end will print. Okay, let's run this program. Let's see what is the output it gives you. Go run main go. You see it prints print hello and main. Okay, but instead of it, what you want is that this hello is executing some some other execution task, and you don't want to make it run with the same inside a main thread. Okay, it execute in its own thread. Okay, so what you do, only thing is Golang is that you put go. Okay, now what is happening when main executes, so main is itself a thread, this is itself a thread, and when it will come here, it will create its own thread. Okay, so that now main is executing in one thread, another is executing another thing. So now main execution will happen like as usual, but what it do is that it will reduce your execution time, because everything is having in the same time. Okay, what I have done is that I have zoom out my screen so that you can see the terminal fully. Okay, so So now what you see is that when I execute this program, you will see that it prints something different actually. Go run main. Yeah, and you see, okay, so because it was faster than it printed. Okay, and now you see is that first time it was printing print hello. Now you see main and very interesting. Okay, why it is doing, why it is happening. The only reason is that because this is different thing and this is different thread and this is different thread. Okay, so what is happening, sometime hello is the other thread is hello is printing before main. Sometime it is, because it's now it's happening in say in different two different things. Sometime it is printing hello, sometimes it's not printing, sometimes it's only printing main. Okay, so if you will see, let me do something more interesting on this one. Let me do something called time. So I will just introduce one more package, which is time. Time dot sleep. Okay, and then time dot second, time dot second, and I will just wait it for 2. Okay. And what I'm assuming is that the above thread will execute within 2 seconds only, because just print hello. Okay, so now you will see that it will be printing hello, print hello also, and main also. Yeah, every time whenever we do, it will do that. Okay. Okay, let's start with a different use case in Goroutine. Okay. So what I will try to do is that I will create uh, 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 what I will do is that I will call this hello function 10 times. Okay, and I will try to wait in this function uh, for 1 second. Okay, uh, and I will just call it from the main method. Okay, ideally what will happen that it will take 10 seconds to execute in the original normal scenario, but when we add Goroutine inside it, it will take only 1 second. Okay, what we are trying to do is that, so what we'll do here, so for hello we will do I equal to 0, I is less than 10, I plus plus, and this one, and I will put hello here. Okay, and meanwhile I will just make it sleep for 1 second. Time dot second multiplied by 1, and I will just call I int. I will just print the I e dot print, and yeah, let me add a here also when it started, when it's end. Okay, just put it here, start, and here add time dot now, and time dot string. Okay, and then what I will do is that I will just copy this one and I will put it here, so that we know that when it start and when it's end. Okay, so this is a normal approach. When you are creating 10, you are calling 10 times this method, so what it happen, it will take 10 seconds. Okay, Let's see it. Yeah, now it's printing one by one, and it started in 2819. Okay, 2819 and 2831. Okay, so it takes 11 seconds. Okay, just one second. Okay. I one mistake I may have done. Let me see. Let me run it again. Started in 29. Okay, so it should increase to 10. Okay, so you see around 12 seconds it takes. Okay, so this is 20 and it went to 14. That means it takes 12 seconds. But if I add go here, okay, and because 2 seconds more it take because of this when I put it, okay, that is fine. So now if I add go here, so now you will see this whole process will take only 2 seconds, because this is creating 10 threads and connectivity is like executing it. Okay, it's not waiting for anything. So let's run it. Oh, I didn't save it. Wait a minute. Didn't save it. You see it? So it executed all the print, but sequence, because it's a thread, any thread can execute anytime. So you will see everything is execute actually 0, 5, 4, 7, 8, 2, 1, 3, 6, 9, and you will see from 8 seconds it take only 2 seconds to execute. Okay, so that is the advantage of Golang. If you have concurrent processes, run it with Go routine, and you will see your program running faster. Okay, that's all in Go routine. We'll talk about weight groups and channel, and then we will add into web application, and we will do some real-time production web applications example for concurrency. Thank you for that.